Hello everyone. In this tutorial, we will be covering the topic of 8 directional movement in Roblox. Today, we'll be achieving the type of movement you can see on screen right now. As you might have noticed, I am using a skinned mesh character. Don't worry though, you can still use Roblox's R6 or R15 characters and get the same results. If you want to use skinned mesh characters, check out my other videos. Those can guide you through setting one up for your project. We'll start off with creating a new local script in the starter character scripts folder. I'll name it Animate so that it will replace the default Roblox Animate script. You can use a different name though. Before I script anything, I've got to set up the animations I will use for the 8 directional movement system. For this movement system, you will need 8 animations, each covering a different direction of movement, and 1 additional idle animation. I will make a duplicate of my starter character and put it inside the workspace, and then I'll set up and publish all my animations. If you need help with setting up your own skinned mesh character and the animations for it, I'll leave a link in the description to my previous tutorial that covers this topic. Alright, now that I've published my animations, we can proceed by deleting this character from the workspace and removing the saved animations. We won't need those anymore. Next, we'll make a folder inside our Animate Script, and I'll name it Animations. Inside that folder, I will add 9 animation objects. These are what's going to hold my 9 animations I need. Now I'll rename them corresponding to whichever direction they're going to represent. You can pick different names if you want to, just make sure you're consistent with the naming of them. Although I do recommend following my naming convention because it will affect the scripts as well. Next, we have to set the animation IDs inside each animation object. We do this following the names of the object and the animation we published. So idle ID goes into idle, forward ID goes into forward, and so on. Now that our animations are ready, we'll create another local script, and I'll rename it to Input. This is going to check our key presses. Inside that script, I'll make a new folder and name it Events. This will hold our events that will pass information between these two scripts. Next, we'll add a bindable event inside that folder, rename it to Movement Input Changed. We need another bindable event. We'll call this one Shift Lock Changed. Alright, now we can get to scripting. First, we will add a reference to the user input service. With it, we can get notified of key presses and other player controls. Then we'll create a function called input_began. This will process key presses. The parameters are input and game processed. We add this function as a listener to the input_began event of the user input service. Next, we do conditional statements to check if the player used his keyboard, and to check if the key pressed is left shift, which is my camera lock key or shift lock key. Add a reference to the shift lock changed event. And now we just call fire on the event. Now we need a reference to our player. We can use local player for this since it's a local script. We also need a reference to the controller of the player module. We can get it like this. The controller is used for reading the current WASD input. Also, we'll need to register the run service. I'll comment the code a bit just to make it easier to read. Next, we'll make a function that's going to run every frame. I like to call it update. The parameter is delta time. This is the time in seconds since the last frame. Add the update function as a listener to the heartbeat event of the run service. Now I'll make a function that's going to process the player's movement input. The parameter is going to be a vector3 called movementInput. We need to cache the player's current movement input. This variable will only change when there's a difference between what the player is pressing and what's been cached to this variable. We initialize this with a value of vector3 0, which just means there's no input. I'll quickly rename this function as I think the name is more fitting. And we just call that function every frame in the update function, and we'll send the controller's current move vector as the parameter. This is our WASD input. Inside our read movement input function, we'll add a conditional statement to check if the controller input is different to the last cached movement input. And if there is a difference, we'll just save the controller move vector as the current movement input. We also need a reference to our movement input changed event. Once we have a reference to the event, we just fire it and pass the current movement input as the parameter. Alright, for now we're done with the input script, so we can close that, and let's go into our Animate script. We start off with caching our player and the character. For the character, we can just use script.parent, since this script will always be a child of the player's character. Add a reference to our character's humanoid using the findFirstChild method. And we need the animator, which is a child of our humanoid. We'll cache a variable called shiftLock enabled and default it to false. This will track if our player has the camera lock enabled. Add another variable called current movement direction. Default it to vector3 0. Structure the code a bit. Get references to our input scripts events. Now we need a function that's going to listen to the shiftLock change event. We add it as a listener to the event. This function doesn't have a parameter. That's because we're tracking whether shiftLock is enabled in the script, so we just inverse the current value like this. We'll do the same for the movement input change event, with the difference being the parameter. This function has 1, and it's a vector3 value. And also, it uses the other event. Then we just cache our current movement direction as the last player movement input. We can do a quick test just to make sure everything works. You can see in the output, the movement direction change is recorded, and so is toggling shiftLock. Great, next we'll load all our animations to our animator. Define a function, call it loadMovementAnimations. Make a call to the function right after its definition. This makes sure all the animations are preloaded into our animator. We'll make a couple of null checks just to make sure everything's ready for preloading the animations. You can also add debug print statements here, just to make it easier to track issues. However, I won't do that because the output tells you which line the error was in the stack. After the null checks, we'll add a for loop. We use the loop to iterate over the animations inside our animations folder. Before we process the animations, we need a table to cache them inside of. I'll call this table loaded movement animations, defaulted as empty with the curly brackets. Now we'll add each animation inside the for loop with the key being the animation's name and the value being the animation itself but loaded into the animator, like this. Let's remove this print statement as we don't need it anymore. We need to figure out what each of our individual inputs prints in our output box. If we go forward, we can see the output is 0, 0, -1. This is our cardinal forward direction, and we need a dictionary with each of these 8 directions and the null vector 0, 0, 0. These vectors are going to be the keys to our dictionary, and the values will be the name of each animation that represents moving in that direction. Back to the script, and we can remove this print statement. I'll define the dictionary right now. You can pause the video once it's done and just copy it. The key values have to be in square brackets. This means that the key is an object value and not a string value. You also have to make sure that you put the name values in the dictionary exactly as your animations are named in the animations folder. This is very important. Once we have the dictionary ready, we'll use it to compare the current movement direction with its corresponding animation name value, and we'll use that name to play the required animation. Now we need to cache which movement animation is currently playing. We default it to nil. Let's define a new function. It will be responsible for playing the right animation. We make a call to this function whenever our input changes, so in my case it's right after caching shift lock input and movement input changes. Inside the function, we'll make a for loop and iterate our newly made movement directions dictionary. I will be the keys of our dictionary, and V will be the value paired with that key. First, we check if our current movement direction is equal to the key, and if it is, this is the animation we should be playing. Next, we check if there is an animation currently playing, and if there is, we stop that animation. After that, we set the current movement animation to the animation from the animation dictionary that has the key same as our movement dictionary value V. And we can just play that animation. I also believe my animations are a bit slow, so I'll adjust the speed right now. You have to do this after the animation was started. Let's do a quick test now. There's a few issues. First issue is once the player loads, the idle animation doesn't start. The second issue is that, while shift lock is not turned on, our player moves funny instead of just walking forward. But if we turn on shift lock, we can see everything works perfectly now. So let's stop the test and fix those issues. First, let's take care of the idle animation loading on start. We'll make a single call to the movement animation change function. This will load the idle animation at the start, since our movement input is vector 3, 0 in the beginning. To fix the second issue, we'll go into this function, and at the top make a conditional statement that checks if shift lock is enabled. We'll also add an else statement. This code works perfectly when shift lock is engaged, so we'll just copy that into the first part of the conditional statement. In the else section, we'll add a check to see if our current movement direction is different to 0. We also add an else statement. Within this section, we'll do a check for our current movement animation that's playing, and if there is one, we stop it. Because of the conditional statement, we know inside this section that our movement input is vector 3, 0, so we have to play the idle animation. We'll also adjust the speed. Next, we'll go to the first section of the conditional statement. Inside here, we know the player is trying to move because the movement input is not a vector 3, 0. Since shift lock isn't enabled, the 8 directional movement shouldn't work either, so we'll override the current movement direction to be our forward direction. We'll check if the current movement animation is different to the forward animation. If it is, we'll stop that animation and force play the forward animation. We also adjust its speed. Let's do a quick test. And there we go, you now have an 8 directional movement system. You can expand upon it as you see fit. Thanks for watching, hope you enjoyed it, and I'll see you in the next video.